Yeah, hello. Good morning, everyone. So yeah. So are you able to hear me? Like, can somebody tell?
Yeah, yes.
Okay, thank you. So today we'll discuss regarding the 10th week. So 10th week, I guess most of you, like all of you would have done earlier also in stats 2, I guess, and stats 1 also. So I don't think so there will be much of the issue regarding the concept and all. But yeah, so if you're having any issue, so I'll go through I guess the activity question and the practice question. But if you are having any conceptual issue also, you can ask. But before that, how is the preparation going on? Like you are having the exam on 13th of March, right? So yeah, how is the preparation going on? The syllabus for this quiz will be from I guess 5th to 8th, but there can be some question like 1 or 2 question can be from week 1 to 4. Okay, so I think so you should mostly focus on from 5th to 8th week. Yeah, so there you can score better marks. 6th week is pretty simple one. 7th is also 5th you should have a command on 5th. 6th is simple and 7th, 8th is also not that difficult. So okay, I'll start sharing screen.
So next week, when there is a revision week, if you could dedicate some time on the week 5 SVD component, because I still feel difficulty in that part.
Okay. So yeah, next week maybe on the Wednesday we'll be having a revision session. So okay, we can share. I'll share that Google form and then you can.
Yes,
like
sir.
if you're having any issue in any topic, so we can discuss those topics.
Yeah. Because I have a lot of difficulty in understanding the entire week 5 content. Week 6 onwards is still okay.
Okay, so
I think majority of people have problems with week 5, so probably we can dedicate some time on week 5.
Okay,
Sir,
sure.
it would be nice if we have a revision session.
Yeah, there will be a revision session on Wednesday. We are planning in the morning time, Wednesday morning or evening, anything. Yeah, so what I'll do, today only I'll tell the team to share the Google form so that you can write the important topics, whatever you want to get discussed.
Yes, sir.
I think
Thank
so
you.
that will be fine.
Yeah.
And apart from that, they'll discuss everything in the revision session, but they'll focus more, like they'll just do the recap of those topics, whatever you'll write in the Google form. Yeah, so for all the 4 weeks, there will be a revision session on Wednesday or I guess Monday. I don't like the date is not fixed. And the next week itself, the mock will also get released. The date is not finalized, but they'll inform you maybe by today or tomorrow. So yeah. So if you're having any issue in 10th week, you ask. I conceptually, if you're facing any issue in that, you can ask. But I guess you have already done all the things.
Notations. Could you please run through the notations?
Okay, notations. So why are you worrying about notations? It's fine. Like this depends on the faculty to faculty how he is representing the notation. Like he has taken some. Okay, I'll go through the lecture slide itself. Okay. Okay, so wherever, like maybe earlier you were taking sample space as S, so he is taking omega, it's fine, right? And he's taking the power set of omega, like everything which is like you are having that sample space, right? And if of that sample space, if you're writing all the event, So that simply is a power set of omega that is representing in some sigma. Generally, we call this as sigma that you will read in modern algebra and all. So
So
it's
why does he use 0, 1 there? We generally use 2 raised to that cardinality of this sample space. But
yeah,
why do, yeah.
So whatever you are having in the sample, he's just taking whenever in that sample, like for example, if you're having head and tail. So if I'm taking, if the event is only head, so he'll represent, okay, head is there, but tail is not there. This sort of thing,
Okay.
like, yeah. So if that event is coming, like for example, this is the four, all the four event that can come out, right? Out of that sample space. Okay, if he is representing like here, nothing is there, so he can represent it as 0, 0 sort of things. Or if head is coming, so head is coming, but tail is not come. This
Okay.
he's just representing in this way. Yeah, it's just a way to represent, nothing like it will not like, it's not a, I guess, conceptual issue, but it's just a way to represent.
Fine, sir.
Yeah. And here it's like, see, if we are having some double, like, so what is it, dice, is throwing the dice. If somebody is throwing the dice, here all the sample space is from 1 to 6. Okay, so this is sigma algebra generally it's representing, and we use this in modern algebra sort of thing, but it's just a way to represent. And all the samples, if you'll see, if you'll take, if you'll just, the power set will be having 2 to the power 6 means what, 32 sets, right? No, not 30, 2 into 4, what is that, 8, 16, 32, 64. Okay, yeah. And if you are having this headed, if you are coining, tossing the coin double times, like if you are having 2 coin, so you'll be having this as a power set to the power 4, because you are having 4 like event, you can say, in that sample. So you can write it like 1 would be 5, and then you can take 1, 4 out of 1, then 4, 2 out of 4, then 3 out of 4, then 4 out of 4, and then all the 4. Yeah, 4 out of 4. So this is how it's the, generally we calculate the total number of power set. Okay, if you are having, if you are throwing the dice, 2 dice, so you'll be having 36 sample space. So 2 to the power 36 would be the power set. That's it. So
Sir,
yeah.
I have a question. That here the sigma is 0, 1. Sorry, I'm not getting that. It is 0 representing nothing happened. Means the any event is not happened.
Yeah, for all, for each of the event, like for example, if we are having this, all the sample space 1, 2, 3, 4, 5, 6, right? If I am just preparing one event, or you can say the subset of this fuller set, right? If I'm taking only one, so that means what, one is taken and others is not taken. So for others it's 0, and for one it is 1. It's just a way to represent, nothing else. Have you
Means
got
either the means event happen or not, right?
Yeah, you can assume that as like, only if you are taking one, so one has happened, other has not happened. For example, see, if I am taking some sample space 1, 2, okay, out of this bigger set, if I'm taking subset as 1, 2 only. So 1, 2 means what? For 1, 2 it's 1, 1, and for others it's 0, right? Have you got the point?
Yeah, yes.
Yeah, so this is just a way to represent. I think he's just representing in this form, and he's just taking the number, all the total number of power set as 2 to the power 6, because you already know how it has written 2 to the power 6. So this is the sum of the axiom of probability, that you already know that the probability of all the samples, like after summing all the things, would be 1. And for the probability of each event would be greater than 0. And if all these sets are disjoint, that means there won't be anything common between them. So if there is nothing common, so if you'll take the union, it will come in the summation part, right? If you're having anything common, so, but if you are having anything in common between all the events, then that is not a disjoint set. Then you will, then you have to see, then you have to subtract the common part from that if you are calculating the probability of the union. Okay, so simply is just probability measure, means the probability is calculating the probability of all the, what you can say, the subsets of that set. Like from the head and tail is the sample space. So what is the probability that you're getting nothing? That would be 0. And what is the probability of getting head and tail? And probability of getting head tail is 1. And then you're having that you're just tossing the coin 2 times. Yeah, if you are not 2 times, you're having 2 coin and that you're tossing. Would you like to create? Yeah. Here, what could be the creative way? Like it's a pretty simple one. Here we can't, I guess. Yeah, Puneet, you can unmute and you can ask directly. Yeah, these are pretty like simple things that I can't think we can do anything in this probability stuffs.
Maybe we could do some examples, visual examples.
For probability,
Yeah, we had some in stats 2 also, and that really helped students a lot.
like see, these are all what you can say examples only. Like for this, we can't do anything. Like for if you are tossing the coin twice, this is sort of examples only. This whenever
Right.
there is
So
some sort
I
of
am
difficult.
speaking. So I'm getting messages, especially from a student who has joined diploma directly, that they don't
Okay.
have the benefit of stats 2. So if we could maybe use some of the reinforcements techniques that will help them.
Okay, so I think so. Whoever has joined the diploma directly, you can ask unmute. Maybe I'll try it to make you understand in a better way. But here is nothing. But yeah, whoever has joined, you can ask me directly. Okay, then maybe it would be better for you also, right? In spite of asking him, you can ask me. And if you are facing any problem, you can just ask me. You can tag me wherever, like in the discourse also. We are not getting that on the discourse also much of the questions. So yeah, you can ask me directly if you have not done stats 1 and 2. You can mail me and yeah, if you need some sort of personal guidance also, like if somebody is like I know yeah, there can be a difficulty, not here, but in some like because this week was a pretty simple one, I guess. So but if you're needing anything else also you can ask me directly. Like if you face any problem in the see here it's not like uh, what sort of creative things I can do here. I don't know in the this stuff, but yeah. See, I'll see there. It's just a we are having 2 coins and we are tossing it. So what sample things we can get if we are tossing? If we have having 2 coins, so what you can get? You can get head right or head tail or tail head or tail tail. You can. Yeah, Manish, go ahead.
Sir, in the case of disjoint set, can we say that summation of probabilities of all the events will be 1?
Yeah, see, I'll tell you. Okay.
Like in the above slides.
Yeah, 1 second. I'll just open some sort of things. Okay, so if you're having some sort of disjoint set means what? Like if this is the total, what you can say, samples. Okay, so if this is A1, this is A2, this is A3. So there is nothing common in them. This is A4, this is A5, this is A6, and this is A7, right? So if you are having, there is nothing common, like this is A1, this is total A3. This is the part, like if this is the total sample space you are getting, right? So this is the one thing, like this is A1, you can see, this is the A2. So if you'll calculate the probability means what? The probability of A1 will be this part of that total samples. The probability of that A2 will be this part. So if you'll do the summation, means what? If you are just calculating the probability of A1, union A2, union all the things, AN, that will be 1 only, right? Because the probability of this plus this plus this plus this. So will come, the summation will equals 1, right? Because you are taking all the, what you can say, all the part of that sample space.
Yes, sir.
Is it fine? Yeah.
Yes, sir.
There is nothing common. If you're having sort of like example, see, if you're having this as a sample space, and if this, sorry, this is A and this is B, then there is some sort of common thing, right? So now you can't write directly probability of A union B you can't write this one. Right? Because you have to subtract this part. Some simple, whatever you have learned in the basic maths, sets and all. Just a simple thing. Yeah. So whoever has not done the stats 1 and 2, you can ask directly. No one here, nobody's watching you, okay, how much you know or not. So you can ask directly. So yeah. So if you have to calculate the probability of this is what, 3 out of 4. So these are all pretty simple things. Again, if you are tossing, throwing the dice, if you are having 2 dices, what and all you can get. You can get in the first, you can get 1 to 6, and for the second also you can get 1 to 6. If you are doing the cross means what? You can get 1 1 on 1 2 or 1 3 or 1 4 or 1 5 1 6. Similarly, you can get 2 1 2 2 2 3 2 4. So 36 event, or you can say all the samples you can get 36, right? So if you have to calculate some sort of probability, so you have to just calculate the what is the number of event, that favorable event that you have to write it here, and the total event is 36 because you'll get 36 if you're throwing a die, throwing a 2 die, right? And then so it's pretty simple things and all. And again, these are the simple probability, basic properties of probability, like A complement means what? If you are having this as A, if you are, this is A, right? If you're having total, sorry. If you're having this as the total event, and if this is A, so that the space which are left will be what? 1 minus A complement, because the probability of this plus this will be 1, right? So the probability of this A plus probability of this A complement will be equals to 1, right? Yeah. So here maybe some of you would have failed a little difficulty. So this is B minus A, B minus A, right? So what is that A union B? A union B is what? This area plus this area, right? Can someone, okay, fine. So probability of what is that? A union B is probability of A plus B, and that you have to subtract because you are taking this as 2 twice, right? So in probability of A also you took this area, and probability B you took this area. So this area has been came twice, right? But the A union B is what? Total area plus this area. So you have to remove once this one. So this is what has been done. This has been removed once. This is how generally you calculate. Yeah, you can ask.
So, won't we discuss activity questions and practice assignment today?
Yeah. Yeah, you can ask the question, like activity questions and all. Here
Like-
I'm just explaining. So yeah, you can ask. There's nothing to be discussed here. Yeah, you can ask the.
No, like in the sense that normally, like in the session, we discuss all the questions of activity and practice. So, are we going to do the same today? Or
Yeah, we are doing the same thing, but I thought if you are facing, some of you have told to just go through that.
yeah, sure, you can continue that.
Yeah, so but yeah, you can ask the first. So the first video has been discussed. If you are having any problem in this activity, you can ask. The first 10.1. Anybody is having any issue?
So, if you could like go through every question.
Okay. Yeah, quiz 2 syllabus is from 5th to 8th week. I told you. And there can be 1 or 2 questions from week 1 to 4. Yeah, that's it. So means if you're having 20 questions, so 10% means 2 questions maximum can be from week 1 to 4. Otherwise, most of the question will be from week 5 to 8. Okay, 1 to couple of questions, like 1 to 3 question maximum can be from week 1 to 4. So that's why I told you to just prepare from week 5 to 6 nicely, and just go through the week 1 to 4, like how to calculate the eigenvalue and all, because those are helpful in week 5 to 8 also. So if they are asking eigenvalue, so that you can't tell ki, it's from week 3 and all, because yeah, you can say you have to consider 1 to 8, but mostly the question will be from 5 to 8. Okay, 1 to 4 will be pretty simple one, and very less 1 and 2 questions. Yeah, SVD, they will ask you. I've seen the question. Yeah, there will be some question from SVD and PCM. So you should be focusing more on 5th and 8th week. 6th is pretty simple, so you'll be able to solve. 7 is also simple, gradient descent, and also 5th and 8th you should focus more. If somebody is focusing more on 5th and 8th, he'll be able to solve most of the question and he'll be able to get the good marks. So yeah, so now I'll go through. So syllabus is fine, right? Syllabus is, I don't think so now anybody will be having any issue in the syllabus part of quiz 2. Yeah. So the first question is a set of all the possible event outcome, all the possible elementary outcomes of a result of any experiment is the sample space. Okay, and now the random experiment, so all of them are the random experiment, rolling a fair die, or if you are rolling a biased die, also biased die means it's favoring more to get some particular value, and tossing a fair coin, or you are tossing a biased coin, all of them are random experiments. Then the cardinality of the sample space of tossing 4 coins. So if you're tossing 4 coins means what? 2 to the power 4 would be the sample number, and then if you have to calculate the cardinality, so 2 to the power that 4, whatever, so 4 into 4, so 2 to the power 6 will be the power set of that event, or you can say the sample space. If the entire probability space, the sample space event probability function satisfies some axiom. Okay, so which of the following is are those? So the probability of an event is a real number greater than or equal to 0. Yeah, it's possible, right? Because probability must be greater than equals to 1. Like greater than 0 is fine, but for any event that is not present, like for probability of getting 5 is 0, so you can say it's greater than equals to 0. The probability of the entire space is 1, like we already have discussed. It can't be greater than 1, because the outcome of some event can, the probability of getting some event out of all the event maximum can go up to 1. If E1 and E2 are two disjoint set, means there is nothing common in that. So if we are taking the intersection of E1 and E2, that is 0. Means if you are adding, if you have to calculate the what you can say union, that will be simply the addition of both the event. The probability of an impossible event is always 1. This is not correct, because the impossible event, so the probability would be 0 for that. And this one is, you can calculate the probability of A is 0.2 and probability of B union C is 0.6. So what you can do, if you have to calculate A intersection B union C, so you can take B union C as some sort of values like D. Okay. So now you're having A union D as 0.7, and probability of A has been given, probability of D has been given. Just consider B union C as D. Okay, so probability of A is 0.2, probability of D is 0.6. So A union D is 0.7. Now you have to calculate probability of A intersection D, that you can calculate, right? So the both will get added and this will get subtracted. So 0.8 minus 0.7, so that is 0.1. And now you have to calculate the probability of getting a face card. Face card means what? King, queen, and joker, or jack, you say. So we are having what? 3 into 4. So 12 cards out of 52 is face cards. So 12 upon 52. So these are pretty simple one. And now you have to, 2 cards are drawn from a whales of a deck of 52 playing cards with replacement. So replacement means what? If you are taking out some one card, so again after getting that, after taking out that card, you are just watching which card is this, and then again you are putting that card in the packet. Okay, so every time you'll be having 52 cards as the total number of cards. So now you are taking out the king. So king will be 4. So 4 into, so for the first time, if you are getting the king, so what is the probability of that? 4 upon 52. And the second time, again, if you are getting the king, so what is the probability of that? 4 upon 52. Both are totally independent of each other, so you can multiply directly. So 4 upon 52 into 4 upon 52. So it's fine. Then we'll move to the second. If you're having any issue till now, you can ask 10.2. So lecture second also, if you're having any issue, you can ask.
What would you not call a random experiment?
What you will call as a random experiment, simple, whatever the experiment we are doing, some sort of experiment where you can calculate some sort of probability and all.
What would not be an example of random experiment?
Okay, not example of random experiment. Okay.
Maybe whose outcome is out of the sample space.
What outcome is?
Out of the sample space.
No. No, that is a different thing you are telling. If you are having some sort of sample space, you are telling if you are getting something else from that. That is what you are telling, right?
Yeah. For example, in the face card example, if I'm not sure if I'm right, I'm just guessing.
Yeah.
In the face card example, if we from a deck of cards, if we are taking one card out at random, and we want face card, so maybe sample space is limited to face cards. But while taking a card at random, we got other number card as well. So will we call that event as not as a random?
What you are telling is a different thing. Like you are telling that if you are having some sort of sample space and the sample, see, first we are defining some sort of random experiment, okay, and then you can't get something that is not in the part of sample. See, if there is some sort of random experiment, is like there. If you are doing that experiment, you are able to get a different set of values. Like if you are tossing a coin, you can get to. If for example, I'm telling if you are doing some sort of experiment where you'll get a fixed thing. Fixed thing means what? If you're doing some sort of experiment, you are getting only that values, only one values, or you can say that there is a, like the sun rises in the east. Okay, that is not a random experiment. The sun set in the west. This is not a random. This is a, you can say this is not an experiment. Like there is a fully, like this is a.
Let's say we can say that if we drop a ball from some height, it will definitely go down.
Yeah. This is not also a random. If you're throwing a, what you can say, ball from some sort of from mountain or something from somewhere, so it will come down only, right? This is not a random experiment. Are you getting the point?
Where the where the outcome is not random, which can surprise us. Right?
Yeah. So there is a fixed outcome. If there is the outcome is fixed. Yeah. So that is not a random experiment. Okay. So there is some sort of things that like you can get values, different values and all. Those are the random experiment, you can say. Okay, have you got the point? Like throwing a ball from somewhere is not a, or the sunrise in this. These are not a random experiment. These are like probable. Like you can say the sure set experiment is not a random. So you can get some sort of random values and all. These are random experiments. Is it fine? Like whoever was asking.
Like, can you explain?
Okay, like I told you, like if you can see, just you told the example of like throwing a ball. So if you're throwing the ball, it will come for sure in the like it will hit the ground, right?
Yes, sir.
So this is a truth. You can say this is not a like random experiment. You are already knowing that the ball will come down itself, or you can say the sun rises in the east. These are simple statements, not an experiment. Whenever you get some sort of random values, if you are getting, okay, if you are like taking out the card from that 52 card, so there you can get a different set of values, right? So this you can call as a random experiment.
When we are like not sure of the event, when we're sure that it will happen, then it's not random.
Yeah, this is not a random experiment. The number
And
of
if
yeah.
I can explain, sir.
Yeah.
So, if we have the cards arranged in an order, and if you are going to pick the first card, we already know what is going to be the answer. But
Yeah.
if we shuffle the card and then we pick one, that is the random experiment.
Correct.
So can we say that a random experiment is a non-random experiment is an experiment in which outcome is the known. For example, whatever we have
outcome is
discussed.
unknown. Yeah, outcome is known,
Yes.
or the severity of that event. Those
Yes.
things. Yeah.
Outcome is known in both the cases actually, but we are not sure about the
There
what
is
are
no
the different.
security about that.
Yeah.
Like the outcome, known outcome, he means that like the truth thing. He already knows that this is going to happen. This is not a random thing, right?
Right.
Yeah.
So yeah. So now we'll move to the second lecture. If you're having any doubt, you can ask. The second lecture, what is that? So second lecture is about the conditioning thing. Like if
Can you go to the lecture one once? That last counting thing.
Okay. Yeah.
Sir, how is this 3 factorial? Like initial 3 factorial, I understand that there is no ordering involved. But what about this other 3 factorial?
So what was the question? Like probability of if you are having this word B A N A N A. Now you have two probability that what is that? 3 pieces are A. Okay. See. Total number. Wait, I need to see. Can you tell me what is the question? Like I have not seen the. What was the question? Probability of getting?
Like if we have this word like banana.
Yeah. These are the words, and what we have to calculate the probability of getting.
If we pick 3 words, those are A.
Oh, okay. So probability of the event is if 3 are picked, and those are A. So if I'm taking out from the 6, 3 are taken out, 6C3, and okay. Oh, sorry, 633, it's fine. And then because there is nothing of arrangement here. Okay, wait. Okay, wait, I'll just go through lecture only, so.
I think the question was first 3 letters A, and then the rest. That is why 3 factorial into 3 factorial.
Oh, okay. So
Not only picking A, most probably.
let us see that one.
We are picking one by one letters.
Okay, I'll see that once. What was the question? Then only I'll be able to. Okay. What is first thing? The problem number of outcomes is fine. Can somebody tell me what was that? Like whether he's asking whether we have to pick only 3 or we have to pick.
No, first 3 letters A, and then the rest. Then the rest of the letters.
And that is.
I think that is not mentioned that we have to pick rest of the letter, but it's asking like three A's.
Yeah, that is 3
No,
is.
I think that is mentioned in the video. He was talking like that, like rest of the letters and all. Like that is why 3 factorial again.
But if he has taken 3 A's initially, then how can
They say 3
how come
A can't be there, no? Because A is same, no, right? So if I am taking out all the 3A, right? So that
then
can't
how
be.
come it?
Yeah, 3 taking A. There can't be 3 factorial ways because all the A are same, right? And even if I'm taking the B N also next, so this also can't be 3 factorial because N is same, so you have to divide by 2.
So that's the confusing part. Like I was also confused. Like what now?
Okay, so I have not seen. So just now I get to know about that.
Take
So
them, try them as Scrabble tiles. The order of the A's and the N's are not important, but they are distinct tiles, alphabets. Just the order is not important.
even if you're asked, if you're telling that, see, if I'm having this all 6, what you can say, alphabets, okay, and if I have to take that A should be there in the starting, rest anything can happen, right? The first 3 should be A. That is what has been asked, right?
Right. So we only take the sample space where it starts with A.
Sir, I think the professor mentioned that 3 pieces are to be picked, and what is the probability that all 3 are A? So that was the question. But I believe he's permuting as well in this. I mean, that's the reason probably why he gets the 3 factorial.
But if all the A's are same, how we can arrange those? Like, there's no meaning of arranging that, right?
Probably because it's a Scrabble tile.
Yeah.
So
Right. They're distinct tiles. Even
that
though
could
the
be the
alphabet
reason.
is same. Yeah, even though the alphabet is same, the tiles are distinct.
Okay. But that also doesn't make it clear.
So if you are facing a problem, we are all the more confused right now.
Yeah, so I need to see what is this. Okay, I have also not seen this like this problem. Okay, I need to discuss it with what is trying to see, like what is trying to take. If see the values, then the probability that the our favorable outcome will change if I'm taking the probability of getting only A in the starting and the rest. If I'm taking okay. If I have to take only I'm having this thing and there is no permutation or there is no arrangement sort of thing, I'm have to just take A. Okay, so that is 6C3 that I'm taking from 6, I'm taking out 3, right?
So if we take it to the cards problem, what's the probability of getting 4
Which
kings in the
problem?
first 4 tries? Let's say we have a deck of cards. What's the probability of picking up 4 kings in 4
If I have
tries?
okay, so that depends on if that is a like see for the first time if you are taking out, so 4 upon 52 would be the probability, like the
Same out
second.
here, sir. Same with the A's. Exactly like this, sir. So if you have 4 kings and the probability of the first one is 4 of 52, same in
Yeah,
banana, the A's would be the first time it will be 3 out of the
6.
6. Yes, sir.
Second times 2 times 6, 2 by 6.
2
No,
by 5. 2 by 5.
Oh, right.
2 by 5, that is fine, but if that will not equals to 3 factorial into 3 factorial upon 6, if you're having this as 3 into 2, that means 3 into 2 upon
So
6.
we don't take the factorial for cards. Why are we taking it for this?
One second. So this is 3 upon 6 is the probability for the first. 2 upon 5 is the probability for the second, right? 3 upon 4 is the probability for, okay, in this way solve. Okay. See, if you'll write this also now, 4 upon 5, if there is no displacement, like see for the 4 king you told, 4 king you have to take out of 52 cards, right? So if you have taken out the first and you've seen that this is the king, right? So the probability of getting that is 4 upon 52, right? But the second time if you are doing, if you're not replacing the card, that means if you're not putting that in the back, right? If you are left with 51 card, okay? So that will be what? 2 upon 50 and then 1 upon 49. So this you can write, right? The 52 into 51 into 50 into 49 as what? 52 factorial upon what? 49 factorial. This way you can write, right? 52 into 51 into 50 into 49. 48 factorial. Okay, 48 factorial. Right? You can write like this. So here also I think so is taking in the first try, like the bananas. If I'm taking, I have to take the first is A. So what is the probability of getting first A? 3 upon 6. Again, second A is what? 2 upon 5. The third A you can get as 1 upon 5, right? Now there is no A.
What
Sorry.
about 4?
Sir, but
1 by 4.
he is using the concept of counting. Why he's applying this? Like why he's writing in this way?
See, just telling the one another way that. So now you are left with what? 3 other, like what is that left? B and N, right? So this is fine, but again for this, see, again you have to see all the combination for 3 B and N. So again that will be what? So you are left with for 3 because you are left with 3 alphabets. This is a one way to solve this, but I don't know how the professor has solved.
But we should not touch B and N now because it is not asked to rearrange.
Yeah, so you have to see all the combination of that. you have to see all the combination of this. So
The different methods are fine, but like he's introduced the method of counting over there, and we are focusing on that. So I'm just curious to know how counting is applied in this particular question. That's what my question is. Yeah.
Yeah, I'm getting your point, but even I need to check this once, then only I'll be able to get back to you. Is that fine? Like,
Yeah, sure.
Take this once and then I'll get back to you. Okay, how we solve this question?
Sir, it's confusing, so we can leave it for now and we can proceed ahead.
Yeah, correct. So yeah, so the next one is 10.2, right? So if you're facing any problem in this, you can ask. So I'll go through just, I'll go in like 2-3 minutes. The first one, which of the following is true regarding the event A and B in an experiment. Assume that A and B are non-zero probability. So if probability of A given B equals to A, probability of A, then this will be equals to probability of B given A will equals to probability of B. That you can see from the conditional thing. Because A given B is what? A union of B upon probability of B equals to probability of A. That means A union B is probability of A into probability of B, right? Sorry, A intersection, not union. So that is a case of, you can say, independent thing. Have you got the point? Like if you are having A intersection of B, that means probability of A intersection B is probability of A into B. And if you again have to write probability of B given A means probability of B intersection of A. That means probability of A into B. So A will get cancelled. So you'll be having probability of B, right? So this is this will be fine. But this is not fine because for this case, A intersection of B should be a probability of A into probability of B, means a case of independent. Then only can't be always true, but can be true if there is a one condition given, probability of A intersection B equals to probability of A into B. Then this condition will always hold. Otherwise, it will not hold. And if A is a subset of B, A is a subset of B means what? If you are having a bigger set B, this is the B, and if you are having A here, right? So this is what the like you can say the intersection, or you can say the what is that intersection or union. So already of A union B is A union B will be B only, right?
Yes.
Right, because A is a smaller part of B. So if you are taking the intersection, so that will be a bigger section. That is it. And the fourth option, if A and B are independent, then there's a mutually exclusive. That is not correct, because in mutually exclusive event, there can't be anything in between, like common in between. But in the independent, there can be common, like because A intersection B is equal to A into B. So there will be some values for A intersection B, but for the mutually exclusive, there won't be, like it's a disjoint set. So there won't be any common between A and B.
Right? But in the question, they've nowhere mentioned that A and B are independent. So even the first option works only when they are independent, right?
No, see, if the first option is probability of A given B is equals to probability of A. So this is given, right? So this is given if A. So that means probability of A intersection B equals to probability of A. So if this is holding, so other will hold.
Okay. Since this holds, it means that they are independent. Does that mean that?
Yeah. Okay. Yeah. So they are independent, so other will hold also. Okay. But for the second option, they have not given anything. That's why it's not correct.
Okay, sir.
Sir, can you clarify that how independent and mutually exclusive is different? I mean, I'm getting confused about why it is different. Sorry.
You are having one event as A, and this is B, right? So there is nothing common in between, right? Right? So this both the event are disjoint, you can say, or mutually exclusive also. So disjoint and mutually exclusive are same. Okay. So if there is nothing common means what? If you have to calculate the probability of A intersection B, so if there is nothing common, so the probability of A intersection B is what? 0. Right?
Okay.
Yeah. But if you're independent means there would be some common thing between them. So they're independent, but the event that's a sample space of this A and B, there is some sort of common thing also. So there the probability of A intersection B would be probability of A into probability of B. So this value should come. So mathematical, you need to check whether it's independent or not. Okay. Just by reading, you can't tell if this both event and are independent.
So why is it PA into PB?
What?
So why is it PA into PB for independent?
This why is it so? You're asking.
Yes.
So that independent event. This holds. That's why we generally tell this is the independent event. Okay, wait, check it once. Why this value is coming this? He has not told anything regarding that, right? Just told that the A and B are independent events. That means the intersection will equal. So the mathematical value of this should be equal to probability of A into B. Okay, like why is this coming this way only?
Actually, it comes from the conditional probability.
Yeah, it comes from the conditional probability. But yeah, this is not. Yeah, that's similar. And if A and B are independent of each other. See, if you're having some sort of conditional thing, right? Okay. Conditional thing means what is the probability of A given B? If they are independent means what? That the happening of B should not impact A, right?
Yes, sir.
So the happening of B should not impact A means what? The probability of A given B should be equals to probability of A. See, if I'm telling you what is the probability of getting A given B and B is not impacting, B is an event that is not impacting the probability, the event of A. Means the happening of B is not impacting anything on A.
Yes,
so the
sir.
probability of A given B would be what? Probability of A, if that is independent.
Yes,
So
yes.
A and B are independent. That means the happening of B is not impacting A. Means probability of A given B would be A. Are you getting my point?
Yeah.
See, if you have to calculate probability of A given B, that means the probability of A intersection of B upon probability of B, right?
Yes, sir.
But if somebody has told like the happening of B is not impacting the happening of A, the happening of B is a different event and B is like totally independent of A. So the happening of B will not impact the happening of A. So there the probability value will also not get impacted.
Yes, sir.
Are you able to clarify? Like,
Yes,
am I able to clarify? Like, see, if A or some sort of like, I'm tossing, you are having one coin, you are tossing that, and I'm tossing a coin. Okay. Whatever the values I'm getting, that will not impact your, because you are coining a different coin, right? So whatever the values I am getting, that will not impact your values, right?
Yes, sir.
Like that is because it's a totally different coin. And I'm having a totally different coin. I am tossing the coin and whatever I am getting, that should not impact your values, right? If there is a connection between them, like A and B, or like your coin and my coin, your coin, the values will get impacted from the values I'm getting, then you can say these are both are dependent values. But the thing is ki, whatever the values I am getting, that is not impacting your coin values, right? So whatever you are getting is totally undependent, like it's not dependent on my values. Okay, so that means what? If somebody has told you to calculate the probability of A will be equal to probability of A given B, because this is not impacting, this values is not impacting your values, right?
So how can there be something common? Shouldn't the intersection be null?
No, see, the intersection, whenever the intersection will be known, that will be a different case. Okay. So there can be in the sum of the event, there can be the, what you can say, the common part can be 0. So that will be both independent plus disjoint. But here we are just discussing about the independent. So just focus on this. There can be some sort of event where the independent part, that the product part, there can be, there won't be anything. But here we are just discussing about how we are getting this. So probability of getting A is not impacted by B. That means the probability of A given B would be probability of A. So the intersection will be probability of A into B. So these are generally the independent events. And if that part, if you're asking that if you are asking that the A intersection B means that the event you are getting and the event I'm having the coin, whatever I'm getting is totally the sample space is a bit different from each other. Okay, and there is nothing common in between them. Then those are generally called as disjoint, or you already know, mutually exclusive event.
Yes, sir.
See, have you got the point, or should I clarify it again?
Sir, got it.
Yeah. So I guess you have done that stats too or not? Like,
So yes.
okay. Stats 2 was would have covered all these things, right? In a great details. Not even, no, stats 1.
Sir,
Yeah.
can this joint event be independent?
Not always, but disjoint event means there is nothing common, right?
Yes.
So if there is
Yes.
nothing common, the product will always be 0.
Yes, sir. Yeah.
Right? So those are independent only. You see, if the A and B are independent, that means what? That can't be a disjoint event for sure, because A and B are independent. And if the product you are getting some sort of value constant, that is pakka, this is not disjoint, right?
Yes, sir.
Okay. But if you are having some disjoint set A and B, you are getting the product as what? You have nothing common in that, and you are
Yes.
getting 0. That is also fine. Like if you are having some A and both are disjoint, can you see any of the event where there is nothing common, but you are getting some sort of constant? That is also not possible, right?
Yes, sir.
Yeah.
Yeah.
It's possible only if you are having one set as a 5 set, then only it's possible.
Yes, sir. Yes.
Right. Yeah. So just for the anything else from the second lecture? For the first lecture, one question was there. I'll check it once again, and then I'll put it on the discourse, or on the Saturday session I'll be coming. So there I'll discuss that. I'll see and I'll discuss once. Okay. From lecture 2, is there anything else? Anyone is having anything?
No, sir.
Okay, so I'll just go through this one. So the A, yeah. So if the intersection of the two event is null, then it's a mutually exclusive event, right? And if A and B are two events of an experiment, then which of the following holds the law of total probability? So law of total probability means what? Probability of A will equals to A intersection B plus A intersection of B bar. B bar will include all the rest part of the B, right? So similarly, we can say this generally we use in the Bayes theorem also, the denominator part when we have to calculate the total probability. Similarly, if you have to calculate probability A and B are two events and both are non-zero, which of the following holds true? Holds true for A intersection B, that you can calculate from the conditional probability. Okay. Conditional probability A given B equals to A intersection B upon probability of A. So the first one is correct and the second one is also correct, because the probability of this is what probability of A given B will equals to A intersection B upon probability of B. So if you'll just cross multiply, you'll get first and second as correct option. Similarly, if A and B are the event and probability of getting A and probability of A and B are non-zero. So which are the following probability of B given A is correct? B given A means what? B given A is probability of B intersection of A upon probability of A, and then you can write it B intersection A, you can write from the A given B. So you'll get 1 values from out of 4. Have you got the point how we are doing this?
So can
B
you
given
this one?
you can write it. So probability of B given A. You can write it like this: probability of B intersection of A upon probability of B, probability of A, right? And probability of A given B is what? Probability of A intersection B upon probability of B. But this value is same for both. So now you can write, so from here you can take out the value A intersection B as probability of A given B into probability of B upon probability of A. You can write it like this. And here also you can write, you can take the value from here. You can write it probability of B given A into probability of A upon probability of B. Is it fine? So is it fine? Whoever was asking the question, is it fine? Now you're getting the point. So this value you can just take out from here and you put it here. So you'll get this one. And this you can take out from this equation, you can put it here, you'll get.
Yeah.
It's fine?
Yes, sir.
We can move further. And then here we have to calculate the in ML Foundation IITM 60% of students are male and 40% are female. And out of the 60% of male, 50% is qualified. This is what has been asked. So 60%, so 50% of that 60% means what? 0.6 into 0.5, that is 0.3. And 40% are male. Out of that 40%, 70% have passed. Means 70% of 40%, or you can say 40% of 70%. So that is 0.28. So 0.3 plus 0.28 will be 0.58. So 0.58 is correct. Right? So now we'll move to the next one. Next one is talking about the random variable and all. Are you having any point, like any issue in second lecture? Nothing, right? So the next lecture is talking about the random variable, that you already know how generally we define random variables and all. So if you are having the sample space for some space, like here, the random variable has been defined. If you are throwing the coin twice, so you'll get this as the sample space. And you have defined a random variable as number of hits. So you can define the random variable in this way. And then for each of the random variable, you can define the probability values also, right? So PMF, everybody knows how generally we calculate the PMF and for the discrete, because here we are just talking about the PMF. So in the next week, we'll talk about all the things, all the continuous, what you can say, the continuous function and all. Here we are just talking about the discrete. In the next week, we'll talk about the continuous things. Okay. So CDF, everybody knows how generally we write the CDF function from the PMF, because here we are talking about the discrete function. So the values will lie from 0 to 1 and the probability of minus infinity would be 0 and probability of getting infinity would be 1, because the CDF function will start from the 0 and it will go till 1, because the maximum value of that probability can go up to 1. And if you have to calculate the probability till some particular value, you have to just calculate the area in the continuous, and you have to add up some of the probability value till that point in, if you are considering for the discrete function, right? So there is nothing like here just plotted the CDF, PDF and CDF for this. Like for example, for this PDF, PMF was like the probability of getting 1 while throwing a dice is 1/6 for all the values by 1/6. But if you are just converting that into CDF, that means for 1 you were having 1/6. So for next you'll add up the 1/6 and you'll get 1/3, I guess. Yeah. So in the same way, you'll just keep adding, and in the final after 6, you'll get the value as 1. So if you have to calculate the till 4, you can just add up all the values till 4, right? So this is the indicative random variable. If you have just defined some like getting 2 head, if you'll this sort of what you can say, yes or no type of thing. If you are getting that whatever the particular value you want, then indicate that as a 1, and if you're not getting that as you can indicate that as a 0. Like if you are tossing a coin, if you're getting head, you can just indicate as 1, and if you're getting the tail, you can indicate like for the other cases you can represent it as 0. For if you're throwing a dice also, so getting 1 you can indicate as 1 because that is the favorable outcome you want, and for the rest of the cases you can indicate as 0. So probability of that random variable, you can say the probability of that indicative random variable would be 1 for your case, and for the other otherwise it will be 5/6, because all the other cases will lie in the other cases, right? So we'll move to that. Here, if you're having any issue, you can ask in third lecture, like random variable stuffs and all. Like which of the following is a true related to the properties of random variable is a true that assigns numerical value to each outcome in the sample space. So like for example, I told you in the head-head, if you are defining head-head as 1 and the rest of the cases as, or you can say that is the indicative one. But if you are for the random variable, if you are defining like the number of heads, if you are throwing 5, the 5 coin, if you are throwing, and you have to calculate the number of, what you can say, the number of heads you are getting in each sample space. There you can indicate all the numbers in the form of numerical values, right? It can be discrete and continuous. So in the continuous, we read about the continuous random variable and all. The discrete random variable can take only a countable number of distinct number. Yeah. And the probability of any event in an experiment will lie from 0 to 1. That is the simple axiom of the probability. So if you're having any issue, you can ask regarding random variable. These are all simple. Which of the following properties related to EMF? So you already know that should sum up to 1, and the probability should be greater than equals to 0. And the probability of each event or each event should lie from 0 to 1, right? It should not be less than 0. The probability can't be less than 0. Like this is also incorrect and invalid because the probability of getting 3 is minus 0.1. That can't be correct. Either the summation is 1, but the any particular sample, the probability of getting that sample can't be negative, right? Either it can be 0 or it should be from 0 to 1, can't be negative. Similarly, you have been given the PMF and for each of the values, and you have to calculate K value. So that means you need to use the basic properties like the summation of all the probability value at each of the point will equals 1, and from there you can calculate. You can just solve the quadratic equation and you get the value of K. Okay, if you are getting 2 values, that means one would be negative, I guess. So negative can't happen. Like negative value it can't take it. It can't take. So the positive value will be the correct one. Similarly, if you have to define the new random variable, that is y equals to x square. So thus, if you are just squaring all the values, like if you are for this range, whenever the range were -2, -1, 0, 1, 2, you can just square it. So for x square means what? 4. And again from here also you are getting 4. That means the two random variable got merged up. That means the probability of getting x square, that means 4 would be what? 0.1 plus 0.2. So the probability of getting 4 would be 0.3. Probability of getting 1 would be what? Probability of getting 1 will be getting from here. So 0.2 plus 0.3, that will be 0.5. So now we are having probability of getting 1 in the new random variable is 0.5. And probability of getting 4 in the new random variable is 0.3. So 0.3 plus 0.5. What was that? 0.5 plus 0.3 is 0.8, and probability of getting 0 in the new random variable is also 0.2. So now whatever the random variable we have defined in the form of x square is having 0 with the probability of 0.2, 1 with the probability of 0.5, and 4 with the probability 0.3. Okay, so the range are what? 0, 1, 2. So to calculate the range, you just have to do whatever has been asked in the to calculate the new random variable. So here it has been x squared. So you just have to square the value of all the ranges, whatever you will have in the earlier random variable. And the probability you can calculate just adding up all the values.
Yeah, means sir, here the probability of getting 4 is 0.3, right?
Yeah, so here you were having x, right? So here it was -1 minus, right? So the probability value was already given 0.1, 0.2, 0. What was that? 0.2, right? So if the new random variable has been defined, y equals to x square or anything, so the range value would be what? You just have to square this value, so it will be 4, 1, 0, 1, 4, right? And if you have to calculate the probability of this new random variable, this y, okay, so what will be, so 4 you are getting from these 2 points, right? So the probability is what? 0.0 and 0.2. So the probability of getting 4 would be 0.3. And the probability of getting 1 will be getting from here 0.2 and 0.3. That will be 0.5, and probability of getting 0 will be from here 0.2. So the new, whatever you have defined, we have defined the new random variable here also. We are getting the same thing. This is also satisfying all the properties of the PMA. Like for each and every point, the probability of greater than 1, 0, greater than equals to 0, right? And the summation is also coming to be 1. So this is also correct random variable. Okay, fine.
Yes.
Yeah. So now we'll move to the next part. If you're having any issue till here, you can ask.
So if you go to that like writing part.
Here.
Yeah. So if here you have written 410, what if there was another number called 3? Then the probability will be 0 for that, right?
Yeah.
Okay.
So if there will be 3, the probability will be 0. Because
no,
we already.
No, like 3 in y equals to x. So suppose we get 3 like by squaring x, but 3 doesn't exist in x.
Yeah, 3. Yeah, the probability would be 0 for all the other cases.
Okay. Okay, so. Okay.
So, okay, we'll move to the next part. So the next part is related to the joint, expectation. Okay, so expectation can be calculated with a pretty simple formula for that expectation. Like you have to just calculate the summation of that probability value into that value, like the range value. Okay, so you have to just do the summation of x into the probability of getting x, right? For all I equals to 1 to n, all the, this is the expectation of x. So the same thing, we have to calculate the expectation for gx, so you just have to write gx and probability of getting gx, right? The same thing you can do. So yeah, here we are just going through the expectation and variance. So the expected value you can calculate, like for the example, for the sum of the faces, he has calculated the expectation and that came to be 7. That you can calculate from the single dice also. For the single dice generally you'll get 3.5. So for the double dice you can directly write it as 3.5 into 2, that is 7. Because for the independent, so for the any cases the expectation will hold its properties of x1 plus x2 will equals to expectation of x1 plus expectation of x2. That will not hold for the variance, because for the variance it will depend whether a and b are dependent or not. So the conditional expectation is simple, like the expected, if you have to calculate the expectation of x given some sort of fixed thing, or not fixed thing, some other conditional thing has been happened. So expectation of x given a, that you would have learned in what you can say in the stats too. You would have used this expectation when you were calculating the Bayesian estimation. In that Bayesian estimation, you would be calculating what the posterior mean value. In that posterior mean value, you were using the expectation of x given a, right? So this is the way you can calculate the expectation. When you were calculating the posterior mode was what? Whenever you were calculating for 2-3 values, whatever you have to estimate, like you have to estimate some parameter theta, and for if you are getting the parameter theta for one fixed lambda or some p value greater than some other value, then you were directly writing this is the posterior mode. But for the mean you were calculating, you were calculating the expected value of that conditional thing, right? So this is how generally you have already used this expectation earlier, like Bayesian estimation. And these are all what you can say, these are the properties, simple properties, like this will hold for all the cases whether a, x and y are independent or not independent. But if you have to calculate the variance, is this formula, expectation of x square minus expectation, that is the mean square, expectation of x square minus mean square, this is the variance of x. But the basic properties is not here. Okay, so these are the basic thing that you should know before this variance, like you should know regarding the expectation and variance. So these are the some of the questions. Which of the following is true related to the properties? You can hold this is the correct. The first one is also correct. Okay, then x, this is incorrect because you should be having x square here. So the first one have A, B, C as correct options. And then which are the following statements? So this will hold for all the cases, irrespective of how x and x2 are related. But for the variance, it will not hold always. For the variance, it should be independent. And then for the variance equals there, it will be what? A square into variance of x, because in the variance, if you have to calculate the variance of a large number of values, so the constant will generally doesn't impact those values, because if you are having variance is what you have to just calculate how that is how the variance of those data, if you are just what you can say, not multiplying, if you are just shifting those values, that will not impact the value of the variance. That's why if you're having b or some constant, then it will not impact in the final values. Okay,
So shouldn't this be minus c square?
Minus b square. No. See, whenever you calculate the variance, there's a square thing will come. So that will square the minus thing, and then the minus will get squared up, and we'll be having minus squared of that will come as a positive. Okay. Whenever you'll calculate the variance of b minus a square, if you'll do, you'll get the in the final thing, you'll get the constant will get squared up. So here the constant is minus a. So minus a, whenever you'll square minus a, it will come as square. Okay, so you should remember this. Okay, have you got the point? Like whenever you calculate, you can calculate with the help of expected value and expectation. Expected, like you can calculate the expectation of x square, and with the help of mean or some other method also, if you are doing, you'll see that whenever you calculate the variance of ax, it will come as a square of x. So here that there a, so see, if you have to calculate the variance of, it will come as a square of variance of x. So a square means what? If you are taking minus a also, it will come as minus a square variance. So it will be a square variance. Right?
Yes, sir.
Yeah. And then you have to calculate the optimum variance, means wherever the variance is minimum, you have to calculate. And then you have to calculate this question is like Smith played 30 balls in the cricket. So you already know if you have to calculate the expectation, and he is likely to score any runs from 1 to 6. Again, both are inclusive, means he can score 6 or he can score 1. Can somebody tell me what would be the expected value for this if somebody is scoring the run between 1 to 6? If he's scoring the run between 1 to 6 and both 1 and 6 are inclusive, what can be the expected value for that single ball? Like what is the expected number of runs that he can score in the first ball? Anyone?
Hello, sir.
Yeah.
The answer would be 21 by 6.
21 by 6. Yeah, 3.5, right?
Yes, sir.
Yeah. So for the one ball, the expected run he can score is 21 upon 6. So for the 30 ball, it will be what? 21 upon 6 into 5. So 21 into 5. So the value would be what? 105 run he can score of the 30 balls, right?
Yes, sir.
Yeah.
Can you
So similar
explain?
to this. Yeah.
Can you explain this question?
Okay. So see, whatever has been asked here, he is telling that a batsman is there and he can score the runs from 1 to 6, means he can score 1 to 6, 1 to 3, 4, 5 and 6, right? I've asked what would be now we have to calculate for 30 balls, like what would be the expected run he can score. So he can, like for example, I'm telling for the one ball, what is the run he can score out of one ball? If we'll get for the one ball, we can directly multiply with 30, because see, what I'm defining here, the number of runs scored I've defined as the expected, like the random variable, right? So the number, what is the number of runs he can score out of 5, 6 ball in the first ball, right? So how generally we calculate the expectation? So we generally calculate the expectation as what? X into probability of X, right? So what is the X for the first value? That is 1. And what is the probability that he can score 1 run out of 6? Is 1 upon 6, right? Similarly, for 2 is 1 upon 6. 3 into 1 upon 6. 4 into 1 upon 6. 5 into 1 upon 6. And 6 into 1 upon 6. That means 1 upon 6 common, 1 plus 2 plus 3 plus 4 plus 5 plus 6. 6 plus yeah. So 1 plus 2, that is what? 6 plus 4 is 10 plus 5 is 15 plus 3 is 18 plus 3 is 21. Right? So the number of runs he can score out of the first ball is 21 upon 6. So this was the expected value of x1. X1 is what? The first ball. The number of runs he can score in the first ball. But what do we have to calculate? We have to calculate for 30 balls, right? So the expectation of x1 plus x2 plus till x30. So we can directly write it as like this: expectation of x1 plus expectation of x2 plus expectation of x3, right? So the first ball is what? He can score 21 upon 6 runs out of the first ball. Similarly, for all the balls, he can offer all the balls, he can score the same runs, right? So 21 upon 6 for all the 30 balls. So to 21 upon 6 into 30. So that is 5. So that is 105. Yeah. Is that fine?
Yes, sir.
Yeah. So similarly for the last one, basic formula of the expected value. So now we'll move to the fifth one. And the fifth one is like the conditional joint distribution. Okay. So in the joint distribution also should not face any issue regarding in the joint distribution only you are having now two random variable at one time. Like if you have to calculate the random variable like this, similarly this generally represent the CDF of that random variable. So if you have this is the this is the way to represent that table. Like this means what? If you have to see what is the probability of this means the probability of y equals to 2 and x equals to 2. This is the probability 1 upon 36 is the probability when x equals to 2 and y equals to also. No, here x equals to 2 and y equals to 2. Here x is represented as the result of the first die and the y represent the absolute value of difference between x1 and x2. So we are just throwing two dices and then this is the one example here shown. Okay, this is the simple table you can plot if you are having joint distribution. That means you are having two random variables. So you can just plot like this. Okay. So from here, this table, I'll tell you everything. Like this, for example, this second row and third column will represent the expected value. The probability of y equals to 2 and x equals to 3. Okay. So if you have to calculate the marginal distribution, where you just have to fix the y and calculate the probability of x where y is fixed. Okay, y equals to 2. So there you can just add up all these values. You'll get the random variable, the marginal distribution for y equals to 2. So now you have got the how generally we calculate the marginal distribution. You just have to fix the one thing and you have to do the summation of other thing. If you have been asked to calculate the marginal distribution for y, you just have to do the summation for all the x. So similar way, this is the conditional distribution of if you have to calculate this distribution f x given y as normal, whatever the table you're having, we just have to divide with the y. Okay. And if you have to calculate the conditional expectation, again the same thing. And again the covariance you generally calculate. If you are having the same random variable, if you have to calculate if you have to calculate the covariance of x and x, that is simply the variance of x. And if you have to calculate the covariance of two different random values, is the way you'll get in the formula as expectation of xy minus expectation of x minus y. And if x and y are independent, means there is no correlation between x and y. Not correlation, there is no, the covariance value is 0. So this expectation of x y will equals to expectation of x into y if x and y are independent. Yeah.
So just to confirm there, the EXY when we calculate E of expectation of XY, we take x is equal to small x, y equal to small y, and then the joint probability of those, right?
Yeah, joint distribution of those.
Yeah. Yes.
So if x and y are independent, the covariance is 0, means expected value of xy equals to expectation of x into expectation of y. This is what is been given in the fifth one, and we'll move to the activity question of that fifth. So here also the CDF you can directly represent that expectation of x1 should be less than equals to x1. And the joint PDF will be PDF generally calculated at some particular value. So the C will be true. Similarly, if you have to calculate if you have to calculate the marginal distribution of x, that means you have to do the summation over y. Okay, so you have to do the summation over y for the joint distribution. Okay, if you have to calculate the marginal distribution for y, that means what? You have to fix the y, means you have to do the summation over all the x. That means you have to do the summation of all the x of joint distribution. Okay. Similarly, you can, which of the following to conditional also, conditional means x equals to y given y equals to y. Okay. And then if you have to calculate the conditional, means you have to divide the joint distribution upon, if you have been given whatever the conditional thing is there, you just have to divide all the distribution, all the, what you can say, all the joint distribution upon the marginal distribution. So you can present this as a, whenever you have to calculate the C, you have to calculate the C, you have to do this. Whenever you have to calculate the conditional thing, or joint also can be calculated. Joint is generally CN, conditional into marginal distribution. Okay. This is a pretty simple, like all the formulas based thing. And then here you have to calculate A and B. So one thing you can do, yeah. So from the hit and trial method, you can solve directly. Whenever you will take A and B, the summation of all the values should be equal to 1, because the probability of, this is a basic property of probability, that the summation at each and every point after doing the summation equals to 1. Okay, till now there is no problem, right? And then again you have to which of the following represent x of given. So what you will do, but you are having this joint distribution, so I told you to divide it with the marginal distribution. So here the conditional thing is y, so you have to divide with the marginal distribution of y. Like for example, if you have calculated this value, so you have to divide marginal distribution. So you have to calculate the you have to calculate the marginal distribution for y equals to 1, and then divide it with all the values of this. So for example here, so you have to divide 0 upon 0.22, 0.20 upon 0.22, and 0.02 upon 22. So similarly, if you have to calculate the marginal distribution of this, so you have, what you have to do? You have to divide 0.10 upon all the summation, 0.10 upon 0.5. Similarly for all the other cases also. Have you got the point? Is it fine?
Yes, sir.
Yeah. So similarly, you can calculate the marginal distribution for all the things. Yeah. So here you have to calculate the marginal distribution of y given x, means you have to divide the joint distribution upon marginal distribution of x. Okay, so you can divide it, like for example, if marginal distribution x equals to 1, you have to just divide all the things with 0.18. 0.18 means when x equals to 1, you are just adding for all the values of y, you will get 0.18. So you can just divide it 0 upon 0.18, 0.10 upon 0.18, right? Similarly for this question, okay, can you tell me some which of the following is correct? Can somebody tell me? For the 7th one.
The second option.
Second option is correct or incorrect?
Correct.
Okay, so only one is correct or other?
First.
Yeah, first is correct. That is fine. How second is correct?
Because this is the property, like we just discussed, that intersection is equal to P of A into P of B. So it's the same thing here. P of A intersection B is equal to P A into PB. It's the same, like for independence.
See, this is for some x.
No, it says then y, x and y are independent.
See, this first option is correct. Okay, if you are having x and y, the marginal, if for some, for even for one thing, it's not equal to 1, it's not equal to the product, then those are independent, right? But for independent, for all the values of x and y, it should hold this. Are you getting the point?
Yes, sir.
For independent, it should hold for all the other, like it should hold for all the values. Like for this cases, if you're having some point, so this thing should be the product of this summation from this one, this value and this value for all the cases, not for some cases. So are you getting my point, whatever I'm telling you?
Yes, like it's not just for independence, but for all x and y.
Yeah, so it should be for all. So can you see that what's the answer given in your, like here it is incorrect, but can somebody check this one? 10.5 7th question.
Option 1 will be correct.
So in your option 1 only is given, right? Correct?
Yes, sir.
Yeah, so the first is only correct. The second will not be correct because here it is mentioned for some. It should be for all the x. Then only it can be. Right?
Yes.
Yeah. Nobody's any issue now in this problem because earlier the answer was incorrect for this question. So again, this is also fine. Can somebody tell me why fourth is incorrect?
Sir, because if we take covariance of the same variable, then that would also will also be 0.
Can you repeat that?
Like if we calculate the covariance of x, comma x, like covariance of x square.
Okay.
So that will also be 0, right?
Covariance of x and x you are asking.
Yes, sir.
See, this is see, if two events are independent, that means there won't be any relation, so it's 0 for pakka, right?
Yes, sir.
But sometimes it's happened if you're calculating the covariance, mathematically it becomes 0, but those were not independent. This can happen, right? This is a simple like logical thing. Like sometimes if you are doing the calculation, so sometimes covariance of xy is what? Covariance of xx. Covariance of xy is what? Covariance of expectation of xy.
Yes, minus expectation of x into expectation of y.
Right. So sometimes it's happened that mathematically it becomes, so the mathematical values we got like this becomes 0. That means, but x and y was not independent. This can happen, right?
But sir, if they are 0, this is 0, then expected value of xy will be equal to expected value of x into expected value of xy.
Yeah, but if this is 0,
yes,
that
sir.
means if like no, if this is 0,
yes,
then it's independent. But if this is 0, this has been earlier given the covariance of x. Sometimes it can happen. The equation we are getting such that the expectation of xy minus expectation of x and y becomes 0, but those were not independent. This can happen.
Yes, sir. So
right.
Example is this that if we take y equals to x, then
yeah, this can happen.
Yes, sir. Then x won't be independent, right? Yes.
Yeah, correct. But this is same, right?
Sir, it is given na that expected value of this is of x square minus expected value of x into expected value of x equals to 0. But x and x both are not independent, right?
Right.
So this is incorrect.
Yeah. So till here, if anybody's any issue, so we'll move to the next one. That will be the last lecture, I guess. So the last one is also simple. Last one generally talks about the binomial, Bernoulli, and what you can say Poisson distribution. So the Bernoulli is simple. If you are having an experiment and you are getting only two outcomes like success and failure sort of things, then that is Bernoulli. And if you repeat those things for a number of times, that becomes binomial. And if you are if in that binomial n tends to very large and p is small, or you can say the poison can be described as in some interval of time, some sort of like a fixed number of things is happening. So that is also a poison. So poison is generally represented in this way: exponential e to the power minus lambda to the power x upon x factorial, where lambda will represent the mean value of that Poisson distribution or the expected value of. And geometric distribution is like if you are repeating some sort of experiment, so when you will get the first success, that is a geometric distribution. And the same thing happened generally. Maybe you would have read about the hypergeometric also. That means out of that population, if you are taking out some sample values, out of that population, if you are taking out the sample, so out of that sample, how many are positive for your, how many are success in that case? That is generally hypergeometric. So this is for the first success, and hypergeometric is for the nth success. And that's it. Yeah. So if you had expectation, you have to calculate. So here you can just write only one thing. So this, I'll ask them to remove this variance. So expectation you already know is P, and that variance is what? What is the formula for the variance of the bundle? P into 1 minus P, I guess. So similarly for the constant, now we have to do it for the 20 independent. That means the binomial got changed to binomial, right? So NP is the expected value. So third is also pretty simple one. You have to calculate the range. For the Bernoulli, it can be 0 and only. For the binomial, it can be from 0 to n, any integer value it can take. And for the geometric also, it can start from the first success, or in the first trial it was successful. So you can take from the first itself. And for the Poisson, it can start from the 0, like the 0 number of things can passing in fixed number of fixed time. And geometric you can represent in this way, like this many times it was unsuccessful and then it got successful, like P is 1 upon 2, so this will be correct option. When throwing a die, what is the expected number values of number of, so for the geometric you can see what's generally 1 upon P or what. I'm not remembering the expectation of geometric thing, that from there you can calculate. There is a pretty simple formulas for all. You'll get the formula, and then you have to calculate. For the Poisson, you generally know e to the power minus lambda. So these are all pretty simple questions. These are all just how generally you represent expectation, how generally you represent the PMF and CDF of any distribution, right? So there was nothing in this week, but one question we have to discuss. So I'll just check this one and tell me if you're having any issue. So I'll go through the practice assignment. Practice is also pretty simple one. You don't have to do anything. So these are all concepts has been discussed earlier 2-3 times, but okay, it's fine. This will be used again and again. So that's why it's just you can say refresher week, you can say. But yeah, any issue regarding anything, then we'll move to the practice one. These are also pretty simple one, but yeah, if you're having any issue, you can ask. So, okay, if you're having no doubts, then we'll move to the practice. Is also pretty simple. The practice, the first question is, if A is the subset of B, then the probability of B given A equals to 1. If you'll go through the solution also, is pretty simple. Like there is nothing, none of the question is like difficult, you can say. The first A, C, and D is not correct, right? Because from A, B, one should be correct and one must be incorrect. Because if A is a subset of B, then if this is holding, then B will not hold for sure, right? And then,
Could you please explain how D is true?
okay, D. So I'll write it down, or from here itself also. If
Also, sir, A option. A is a subset of B. So if A happens, how can we guarantee that B will also happen? Of course, the probability increases, but cannot certainly say that B will happen.
Okay. So the first option, A is what is the probability of B given A equals to 1, right? So see, how can we write this? Probability of B intersection of A upon probability of A, right? This is what has been asked. Yeah. So A, if A is a subset of B means what? This is B and this is A, right? So the intersection of A and B would be what? This area only. So this will be what? Probability of A upon probability of A equals 1. Have you got the point? Whoever was asking. Is it fine?
Otherwise, I got, but diagrammatically, I am quite confused.
See, this is B. This is this is B, right?
Right, I got.
Okay, and this is the subset of B. This is A.
So we know an event has fall in the subset of A, and now we want to find the probability. Okay, right, okay. Yeah, it will be what.
Right. Now we are moving to the fourth one. So probability of A given B is greater than probability A given B is greater than probability of A. Means what? Probability of A intersection B is greater than probability of A intersection probability of B. Right? So what has been asked is now we have been then if this is given, then this will hold or not. Okay. So now it was asked probability of B given A. So this will be equals to probability of what? B intersection of A upon probability of A. So this value is greater than probability of A into B. Means, for example, I'm taking this as 10 and this as what? 5 into 1. This I can take, right? So if I'm taking this, not this value, because again, if we'll divide this, some sort of constant. Okay. What has been asked is it will hold true. Right? Probability of B given B will be greater than probability of B. Okay. So yeah. So this value, if I'm writing, because this is greater than this, we already know this is greater than probability of A product of probability of B. If I'm dividing into the probability of A, so this will hold, right? Because see, this is greater than means what? This is greater than equals to greater than this value, right? Because this is greater than, because B intersection of A is greater than probability of A product of probability of B. So we can write this equation. If this is getting, we are just cancelling it, or what you can say.
Yes, I got it now.
Yeah.
Thank you.
This you can write like this. So the second one is what? So any issue in first one? The first equation we have solved. This third D also. Out of B, like if you're whatever we have written in the A, we can just write in the similar way for the B, and we'll check whether it's coming 1 or not, whether it's getting cancelled or not. Okay, similarly for the C and D, we have already discussed. Okay. Again, for the second one, there's a random experiment of selecting numbers from a set of integers from 1 to 20. Both are included. Assuming all the number are equally likely to lag, let A be the event selected be odd, and so A is an event Okay, so that will consist of all the odd number. B is the invert that consists of all the number divisible by 3. Now you have to choose whether A and B. So you have to just calculate the A intersection of B, and whether you have to check whether product of A intersection B equals product of A and product of B or not. The probability of A product of probability of B or not. If that is holding, then it's independent. Otherwise, it's a dependent, right? So it's holding here, so it's independent, right? Any problem in this? So again, here is Mayur rolls a fair die repeatedly until a number that is multiple of 3 is observed, right? So the probability of getting a number that is multiple of 3 is what? 1 upon 3. So 1, 2, 3, if I'm just taking 3 consecutive number, 1, 2, 3 or any number. So if you will take 3 consecutive number, out of that 3, 1 will be divisible by 3. So the probability of getting any number that is divisible by 3 is 1 upon 3. And not getting that is 1 minus 1 upon 3, that is 2 upon 3. So 2 upon 3 times of n minus 1. N minus 1 times we have not got, and nth time we have got. So that means 2 upon 3 to the power n minus 1 into 1 upon 3. Have you got the point? So now the Sally wrote an exam that contains 20 multiple choice questions. Each question has 4 options out of it. So this is also like you have to, but each option has 4 options out of which one is correct. Okay, so he'll get 1 marks for that. And he knows that the correct answer for 10 questions, and for remaining 10 he just randomly choosing. 18 marks he has to get. That means 10 is already corrected, and 8 he has to choose out of 10. So 10C8, whether A, okay, A is fine, 10C8. And then for the correct option, 1 upon 4 is the probability. So 1 upon 4 times of 8 C has to get, like 8 C has to correct. So 1 upon 4 into 8. And the incorrect 3 upon 4. Means 3 upon 4 is the chance to get, will be incorrect. Because out of 4 options, if 1 is correct, so the probability that since choosing the correct option is 1 upon 4 and not choosing is 3 upon 4. So 3 upon 4 to the power 2 and 1 upon 4 to the power 1 to the power upon 4 to the power 8. Because 8 correct things he has to do, and 10 she is already getting, so she'll get the 18 marks if she is doing like this, right? Have you got the point? I think I don't think so anything is required to explain this, right? Okay, then we'll move to the next one. So again, it's also the solution has been given. Suppose the number of runs scored of a delivery is uniform from 1 to 6, and all those, like all each ball is playing is independent of the other balls, and the batsman needs to hit the ball till he hits a 6. So what is the probability that he needs fewer than 6 deliveries to do so? So probability of hitting, what is that? Hitting a 4 is 1 upon 4. Not hitting is 1 upon hitting a 4 would be 1 upon 6, and not hitting would be 5 upon 6. So he needs fewer than 6 ball, means he needs 1 to 5 balls. So you can just add it till 5 and you'll get 0.6 as the answer. And now you have to calculate the covariance of x. So this is bit calculative. You have to calculate the expectation of xy for each thing, and then you have to calculate the expectation of x, and then you have to calculate the expectation of y. Do the calculation, expectation of, just do the simple addition, like subtraction, like how you'll calculate the expectation of xy. Joint distribution has been given already. Okay, for each of the every point. So x and y you will be getting for all the points. See how you'll calculate this. You have to calculate the expectation of xy. So xy and the fxy. So you have to do the summation x for all, like for all the points you already know. Like for example, if x is 1 and y is 1, for that x11 you will write it x11. Okay, plus if the x is 2 into f1, y is 1 into f of the joint distribution of x21. Similarly, you can do for all the things, you will get this one. And for expectation of x, what you will do, you just have to take the marginal distribution of x. Okay, and then you have to calculate the expectation of x, like x into f of x. This is a marginal distribution. Similarly, for y, you have to calculate as y into f of y. This is a marginal distribution. And then you have to do the calculation. That's it. So here you have to calculate the conditional thing, like you have to divide the joint distribution of xy upon the marginal distribution of x equals to 2, right? That you can calculate. A1 you can calculate directly. The summation of this, all the values should be equals to 1. So A1 you can calculate with a basic property of probability, and then you can just divide it with the marginal distribution when x equals to 2, right? This means this one plus 1.125 plus A1 plus 1.25 0.25 plus A1, you have to divide it. Okay, and then here the joint distribution has been given. You have to calculate the value of A. So what you can do, this is a discrete thing. So x and y can take 0 and 1. So you have to just write all the conditions. Like you have to take x equals to 0 and y can be 0. X equals to 1 and y, like 4 cases will be there. X equals to 0, y equals to 0, x equals to 0, y equals to 1, y equals to 0, x equals to 1, and both are 1. So for all the cases you have to write and do the summation equals to 1, you'll get the value of A, right? Similarly here, you can take all the x can take 1, 2, 3. Just have to use the basic property of probability, do the summation, equates to 1, you'll get the value of K. Right? So again here, the PDF has been given, CDF has been given. So you already know the relation of the D will directly be equals to 1, because the CDF, in the CDF, after the fourth, after the end point, it will equals to 1, because after this 4, every time the distribution will be having the CDF will have the probability as 1. A also you can calculate. A will also will be equals to 0.2. B will be equals to what? B will be equals to this, the difference of this second and 2 and 1, that means B equals to 0.4. C also can be calculated, the difference of this and this, so 0.1, and then 4 is simply the difference of 1 and 0.7, that is 0.3. So you can calculate it directly. ABC can be calculated, and then you have to evaluate A plus B plus C plus D. Similarly, a series has been 4 matches between England and India has been played, and you have to calculate the random variable x, which represents the absolute difference between the number of matches won by. So matches won by the India can be 0, 1, 2, 3, 4. Similarly, for the England also it can be 0, 1, 2, 3, 4. So you can just do the difference and get the range of x. Similarly, here you can just write there are 5 multiple choice questions asked in the exam, and 70% that is solve the correctly. That means 0.7 is the probability that she'll solve the question correctly, and 0.3 that she'll not solve that. And now what you have to calculate? For the x equals to 1, so means out of how many questions are there? Yeah, so 0 to 5 is there. So out of 5, if 1, 0 is doing correctly, so 5C0, and then you have to write 5C0, and she have done the 0 question correctly, means 0.7 to the power 0 into 0.3 to the power 7. Similarly, out of 5, she has done 1 correct. So in similar way, you have to just write and calculate. Simple calculation. Okay, and then in a horse race, a player has to cross 12 horses. So that he'll clear each horses is 2 points. So what is that? Either he'll cross all the horses or he'll not cross one. So what you have to do here? Either you have to just calculate the addition of both the conditions. Means the first condition is he is crossing all the horses, or he's crossing 11 horses only. Like whether he's crossing all the 12 horses or he's crossing 11 horses. For the 12 horses, 2 upon 3 to the power 12, and for the 11 horses, for the last one, 2 to the power 3 upon 11 into 1 upon 3, because he's not able to cross the 1. Okay, right? And out of that 12, because there are 12 horses, so you have to choose one. So 12C1 into 1 upon 3 of not choosing into 1 upon 3 that horses he is not able to cross, and 11 horses that he has already crossed is 2 upon 3 into to the power 11. Okay, so this was the.
So can you please go through 11th question once again? Yes.
Okay.
I understand the absolute difference part. How do we take the difference?
Difference.
Yeah, how do we take the difference between those two sections?
Okay, so if yeah, so if India is winning like 0, 1, 2, 3, 4, right? And England is also so 0, 1, 2, 3. So just do the difference 0 minus 1. So everything will come from point minus 4 to I guess 4. Everything will come. Right? 0 means 0 minus 0 is 0. 0 minus 1 minus 1. 0 minus 2 minus 2. So everything will come here. If you have been asked regarding the difference one. So you don't have to think whether the negative, how can some team can win the negative matches. Because if somebody has asked you, just you have to calculate the difference of the ranges, then the difference of the ranges will be like this. But if they have asked regarding the absolute difference, then you have to see. Okay, you have to just do the mod, right?
So we get the difference from 0 to 4 only.
See, if some India has won 0 match, then England will win all the 4 matches, right?
Okay, yes.
Yeah, right. So 0 minus 4 is
Yeah.
minus 4, right? But if the absolute thing is asked, so 4 will be the answer. But if India has won 1 matches, the England can win only 3 matches, right? Because 4 matches are there. See, if India has, see, all the values will not occur. If India has won 0 matches, so the England can win 4 matches, right? So the minus 4. If I have to ask, I minus E have been asked. Okay. If India has won 1 matches, then England can win 3 matches. So 1 minus 3 is what? Minus 2.
So,
right? If India has won 2 and England also 2, so 0. If India has won 3 and England has won 1 means 2. And if India has won 4, the England will win 0. So 4, right? So this is the exact thing. But if they have asked regarding the absolute, 4, 2, 0 is right?
Yes, sir.
Yeah. So yeah, so we have discussed everything. So now we are left with what you can say, only one question that I'll discuss in the next meet. And then today I'll ask them to share the Google form also. And you can write the topics and all. So fifth is a bit important. So I've told you, you can just prepare the from 5 to 8 if you are not having much time. If you are having time, you can go through the first to fourth video also. Like first to first, just go through the graded assignment and practice, how to solve the basic questions and all. You should be knowing how to solve the eigenvalue and all. So eigenvalue and eigenvector, you can't say it's from third week or fourth week, because everywhere you are like calculating eigenvalue, eigenvector. So those sort of things can be asked. And what is left? And from the first week is a pretty simple one. You can be asked regarding the calculate the, like you have been asked in the quiz one. Okay, the similar type of question can be asked, because not much concepts are there from the week 1 to 4. So I'll tell, I just you should just prepare from 5 to 8 and just go through the lectures, not lectures, you can just go through the assignment question from week 1 to 4, and that will be sufficient, I guess. So if you're having any issue in this week, you can ask. You can ask me like wherever you want to ask discourse also. You can ask on my mail also. Okay, if you're having any problem, you can ask from the, yeah, you can ask me. You can just tag me on the discourse, or you can just ask. I'll see. I'll just reply there. Or you can mail me also. Okay, is it fine? Hello.
Yes, sir. Thank you, sir.
Yeah, thank you. So, okay. If you're facing any issue in other like topics also, you can just mail me, and then we'll just discuss that regarding that topics also. And otherwise, the Google form will be shared today. Okay,
Sir,
then.
could you please have a look at the week 0? Actually, I was not able to solve this question. I'm not getting from
Week
where to
0
start.
is like some sort of, you are
The week
directly from,
join.
you came
No, sir.
directly.
No.
So week 0 content you already solved, right? In stats 1, 2, right?
Yeah.
So, but those are not much important. But you can just mail me the question and I'll just send you the solution.
Just I will try it once again. Otherwise, I will mail you. Put it on this course.
Yeah, you can mail me. The mail ID you already have, like Vishal@. Okay. Okay, then it's fine. Then we'll just wrap up. Okay, thank you, everyone.
Thank you, sir.
Yeah, thank you.
Thank you.
Thank you, sir.
Yeah, thank you.